Bismillahirrahmanirrahim. Acceleration. Now what we know, acceleration is the rate of change of velocity. The rate of change of velocity with respect to time. এখন যখনই আমরা বলবো the rate of change of velocity with respect to time, আমরা বলবো ddt, এটার মানে হচ্ছে কি the rate of change with respect to time. এখন the rate of change of what? Velocity, তাই যে এখানে হবে velocity. So dv dt, this is equal to acceleration. ddt এটা হচ্ছে differentiation operator. Okay, so ddt means the rate of change of what? Velocity with respect to which one? Time, t. Okay, আচ্ছা এখন now we already know that v is equal to dx dt, the rate of change of displacement, right? If it is along x direction, so we are considering here only in x direction, so the rate of change of position with respect to time. Okay, so if I replace the value of v over here, then what will happen? This ddt is going to be there. V I will replace by dx dt. So if I combine them, what will happen? d2x by dt2. Now you might be thinking, sir, okay, d into d, it became d square. T into t, it became t square. But why d into d did not become d square? Actually, it is not being multiplied. It is said double differentiation. See, x, we will differentiate 1, ddt. Then again, we will differentiate the same thing, right? So ddt, number one differentiation, then again ddt, that means double differentiation. So how do we represent this double differentiation? d2 by dt2. এটা কিন্তু d স্কয়ার পড়া যাবে না, এটা পড়তে হবে কিভাবে? d2 dt2 of x. So whenever we will read this, we will say double differentiation of x, double differentiation of x. Okay, so we know that if I differentiate x once, we will get velocity. If we double differentiate the position, we will get the acceleration. Okay, this will sound much more familiar and easier when you go through calculus. Okay, but for now this much idea is okay, I feel. Okay, so is it clear? Do you understand? Acceleration is the rate of change of velocity, and velocity is the rate of change of displacement. So whenever we combine them, it becomes double differentiation of displacement. Is it okay? Listen, if you do not understand, you need to communicate. Okay, so please communicate. If you have any doubt in your mind, you need to ask, sir, I did not understand the third part, fourth part, or something like that. No? ওকে সাইফুল, তুমি এখনো হাত তুলে রাখছো, কোনো ডাউট জিজ্ঞেস করতে চাও নাকি এমনি হাত তুলে রাখছো?
না স্যার,
হাত নামাই ফেলো। আচ্ছা ঠিক আছে, ওকে। Now we have the position versus time graph. We already know this type of graph, right? But today we will try to draw this graph from an equation. Acha. If you come to page number 127, you will see that an equation is given: 18 meter plus 12 meter per second into t plus, minus 1.2 minus 1.2 meter per second square into t square. Now this is the equation, okay? So we can see that this is displacement. This is the equation of displacement, and it is dependent on time t. If you change the value of time, what will happen? The displacement will change. This is true, right? Whenever a body is in motion, with respect to time, the position will change. In after 1 second, the body will be at a certain displacement. If you put the value of t as 2 seconds, that means after 2 seconds, definitely the displacement will not be the same. It will change, right? If it is moving, okay, so the displacement will keep on increasing with the increase of time, right? So they have formed a table here, table 3.1. If you take a look at the middle right corner of the page, okay. Now how did they find this table? Okay, we can form the table in this way. The time we will choose, if I put 0, then what is the value of x that I'm going to get? It will be written here. If I put time t is equal to 1 second, what is the value of displacement I'm going to get? It will be put here. So for several value of t, we will find different values of displacement, right? So from this table, actually we can draw the graph. Along x-axis, we will put the value of t, 0, 1, 2, 3, 4, 5, likewise I will go. And along x-axis, sorry, y-axis, I will put the displacement, that is s, okay? So if I put it, as you can see, this is a quadratic equation, a square is there. This is not an equation of a straight line. If the equation was of a straight line, then it would be like this, y equal to mx plus c, as you studied in coordinate geometry in SSC level, right? X to the power 1, y to the power 1. Then it is a linear equation. But if there is a square, then what will happen? It is a quadratic equation. Now what does quadratic equation means? The power of the variable will be 2. And the shape of that graph is kind of U shape, okay? Either it will be like this, or it will be like this, or it will be like this, or it will be like this, okay? So here we can see, if you go to the next page, they have drawn half of the okay, they have drawn this much only, okay? As we know that time cannot be negative, that is why we will not get the rest of the part, okay? Time can never be negative. You can never measure the displacement at the time minus 1 second. This is impossible, okay? So we will have only the positive part of this graph, and which will look like this. Always remember the quadratic equation, it is a curve, not a straight line. If it is a straight line, then it will be x to the power 1, y to the power 1. Okay, Acha. And you must remember that from the position versus time graph, if I find out the slope, sorry, I forgot the word. So from this graph, if I find out the slope at any point, I will be finding out the, can anybody, the velocity. Very good. From distance versus time graph, if I find out the slope, then I will get the velocity. Now, as you can see here, it is a curve, right? Not a straight line. If it was a straight line, then only one slope would be there, right? Only one slope would be there, because a straight line has a slope, one slope only. Doesn't matter which you measure where, okay? You can take any 2 points and measure the slope, it will be the same. But as it is a curve here, at every point, the slope is going to be different. That means the velocity is different throughout the journey, okay? As the velocity is changing, we can say that there is an acceleration. So when there is acceleration, it will be a curve. Is it okay? Make a clear communication with me, okay? If you are not getting my points, then you must inform me. Is there anyone who did not get whatever I said? These are all, the basics that you have studied in SSC level. Okay, only the derivative part, the derivation of differentiation part. Other than that part, see, these things you already know. Okay, because in coordinate geometry you have studied this. So if you want to find out the slope at this point, okay, then what you need to do, you have to actually draw a tangent here, and on the tangent you need to take 2 points which are very close to each other to get the accurate result. Okay, the closer the points, the accurate the result is. Okay, so and now if I want to find out the slope at this point, then what will happen, I will draw a tangent at that point and find out the slope of a tangent. Now the slope we can find out always of a straight line. That is why we need to draw this tangent, which is a straight line. Okay. So at every point you will see the tangent will be different. Okay. At this point it will be like this. At a point above that it will be, a little bit more inclined. So at every point we are getting a new slope. So from this graph you know that the slope gives us the velocity. So at every point if it is different slope, we can say that it is different velocity. So different velocity means there is acceleration, which is our topic here. Okay, acceleration. So this is position versus time graph. Then we have the velocity versus time graph. Okay, from this equation, if I want, I can find out the velocity. Now before that, I need to tell you about a formula of differentiation. Couple of formulas actually. I already told you that these concepts might seem a little bit harder to you, but the harder things can only be softened by trying again and again, by studying again and again. So at this HSC level, you need to actually revise the studied, all the things that you have already studied, you need to revise it again and again. Then only actually you will be able to, clarify the things. Achha, okay. Moshe, from the last class, I am noticing that your camera is off. Can you see me? Okay, he can see. Achha. So from here, if I want to find out the velocity, I need to differentiate it, right? If I differentiate it with respect to time, then only I will get the velocity, dx dt. Now, if I'm differentiating this side, I need to differentiate the opposite, the right hand side also. Now, to differentiate the right hand side, I need to know two formula of differentiation. I actually told you to memorize a couple of formula from the vector chapter. Page number 76. There are 12 formula of differentiation. I told you to memorize those because those we are going to use now. Okay, let us see. At first, dx constant. Whenever we differentiate a constant with respect to what doesn't matter, it is a constant. What does constant mean? The thing that will not change. Okay, even though all other parameters are changing, the constant will never change. So if it is not changing, if something is not changing, what is the rate of changing? Zero, correct or not? If it is not changing, the rate of changing with respect to time or anything will be zero because it is not changing at all. That is why whenever you differentiate a constant, it will be equal to zero. Always remember that, okay? This is the first formula that I taught you from differentiation. Whenever you differentiate a constant with respect to what does not matter, okay? Here, ddx or ddt or ddv, whatever it is, does not matter. That if it is constant, then it will be zero because the constant is such a thing which never changes. Doesn't matter you are differentiating or taking the rate of change with respect to what. Okay, it is constant, it will always remain the same. So that is why the rate of change of constant is zero. Number two, now let us say we are differentiating with respect to x, and here also we have x. See, similar. The formula that I'm going to write, it is only applicable when these two are same. The power might be different, okay, it might be a number or anything else, but with respect to x, I'm differentiating x. If it is same, then only we can apply the formula, which is going to be our this case, okay. So then what will happen, this power we will write first, okay, then we will write x and the power will be reduced by 1. This one we can write. Very important formula throughout your entire life. In physics, this formula is going to be used the most. Okay, these two formula we will be using the most. So whenever you will see a constant, I will differentiate it, I will write it 0. Then I will not explain again, okay? Please remember from now on. So constant, you differentiate, you will get 0. And x, this is a variable, right? So with respect to x, I'm differentiating x. Then we will write this one is equal to n. This will come down, okay? X to the power n minus 1. The power will be reduced by 1. So now let us try to apply this formula over here, okay? Let me erase the first one so that I have a space to write it. Now, at first we have 18. Can anybody tell me whether 18 is a constant or a variable?
Constant.
Very good. 18 is a constant. Okay. Why? You see 18, 18t. Out of this, 18 is variable because 18 is constant because the value of 18 can never be anything else. It will be 18 only. Does not matter you change the time. After 1000 years also, this 18, the value of 18 is going to be 18 only. Okay. But 18t, this is a variable because the value of 18t is going to change if I change the value of t. If I put the value of t as 1, the value of 18t is going to be 18. If I put the value of t as 2, the value of 18t is going to be 36. So 18t is changeable, correct? So that is why 18t, it is a variable, 18, it is a constant. I hope it is clear. Okay. So you know that we have to differentiate this side, okay? We will differentiate this one, we will differentiate this one, and we will differentiate this one also. Here actually we can forget about this units, okay? So see 18, it is a constant. If I differentiate a constant, it will become 0, we already know. Now 12t is there, 12, it will be there, we will differentiate t. So let me write dt t. Okay, so actually the way many students remember it, that dx by dx কাটাকাটি চলে যায় is equal to 1. Yes, the answer will be is equal to 1, but this is not the way to think it. You should think about it using the formula. You might ask, sir, how I will apply the formula here? There is no power. There is power. Whenever there is only x, the power is 1. Whenever there is x, only x, okay, the power is 1. Now if I want to apply this formula here, if you take a look, this power I will write first. So the power 1 I will write first, then x to the power, the power will be reduced by 1. So 1 will be reduced by 1. So 1 into, it will become x to the power 0, and x to the power 0, anything to the power 0, we know it is 1. So 1. This is the way to keep it in your mind, okay? Not like, কাটাকাটি চলে যাবে and we can write 1. This is the way. So here also we can see, but যদি মনে রাখতে চাও আর কি, তো তাহলে ddt এরকম যদি সেম সেম থাকে উপরে নিচে 1 ধরে নিতে পারো, ঠিক আছে? এটা 1 ই আসবে, তো এটা ফর্মুলা অ্যাপ্লিকেশনে দেখাইতে হবে না। So it will become 1 minus 1.2, it is a constant, it will stay here. We will differentiate t square, ddt t square. Now whenever I'm differentiating t square, okay, 0, we can omit this. 12 into 1 will become 12 minus 1.2 is going to be there. Now, whenever we differentiate t square, we need to apply this formula. See t, same. And there is a square, the value of n, here it is 2. So the power I will write first. So 2, I will be writing here first. Then I will write the variable, that is t here. So t, and the power will be reduced by 1. So 2 minus 1. Did you understand the application of the formula?
Yes.
Okay, thank you. Now let us see. 12 minus 2 into 1.2, it will become 2.4. T to the power 2 minus 1 is 1. So, ऊपर power 1 होले, we generally do not write the 1, okay? So, this is the velocity because we got it by differentiating the displacement, okay? So, now if I want to find out the velocity versus time graph, this equation is enough for me. Why? Because from here I will be able to draw a table. Okay, t and v. I will choose the value of t is equal to 0, t is equal to 1, t is equal to 2. I will take several values of t and put all of them here, and we will get a respective value for v. For each value of t, I will get a value of v. So I will write them here. I will put them in the graph, and then I will get it. Is it clear?
Yes, sir.
Okay. So, Acha, can anybody tell me, we know that by differentiating displacement, we get the velocity. If I differentiate the velocity, what I should get?
Acceleration.
Acceleration.
Very good, acceleration. So can you find out the value of acceleration for me? Okay, from this line, you have to differentiate this line, right? So when you differentiate this line, what will be the outcome? I will give you 1 minute or 2 minute time. Kindly find out the acceleration. Okay, just I found out the velocity from displacement. Likewise, from this velocity equation, find out the acceleration and tell me the answer. I will give you 1 minute time.
শুধু -24 আসবে, right?
Right. So what will be
So
the
acceleration will be -24.
acceleration? Will be -24. Okay.
জানি না, confused.
No, correct. We will differentiate it again to get the acceleration. So whenever we differentiate 12, it will become 0, and 2.4t. If I differentiate it, 2.4, it is going to be there. Now t to the power 1 is there, or else we can just actually write, if we differentiate dt, then what will happen? dt, it will become 1, okay? So
আমি 2.4 কে 24 ধরছিলাম।
2.4 কে 24 কেন ধরছো?
বুঝছি যে 24 ওইটা।
না, এটা -2.4. Okay, meter per second square. That means it is having a deceleration or retardation. The velocity is decreasing. Okay, this is actually clear from the previous table also. Okay, see the value of t when it is 0, the value of t is 12, because this part will become 0. Whenever value of t is 1, then 1 into 2.4, 12 থেকে কোনো কিছু minus করলে it will become a lesser value than 12, right? Whenever you put t is equal to 2, so 2 into 2.4, you have to subtract from 12. So the velocity is actually decreasing, so it is a deceleration. Okay, very good. And if you come to page number 130, you will notice that the velocity versus time graph, it is a line of a negative slope. It is a line of a negative slope, and the acceleration that is here is uniform acceleration. Now, I remember many of you getting confused between uniform velocity and uniform acceleration. What does uniform velocity means? The velocity is not changing. Whatever I say uniform, that thing is not changing. So uniform velocity means velocity is not changing. So if velocity is not changing, acceleration is 0, because acceleration is the rate of change of velocity, and velocity is not changing, so the rate of change of velocity is 0, acceleration is 0. But when I say uniform acceleration, then what do I mean? The acceleration is not changing. That means, say the uniform acceleration is the case of a falling body. Acceleration due to gravity. Whenever I leave this body, okay, at first, when t is equal to 0, the velocity of this one is going to be 0 because it just starting to fall. Then after 1 second, the velocity will become 9.8. Okay, so the increase is from 0 to 9.8. In 1 second, the velocity increased by 9.8. In the second, the velocity will again increase 9.8. So 9.8 plus 9.8, after 2 seconds, the total velocity is going to be 19.6, right? So in every second, you will see 9.8, 9.8, the velocity is increasing. So as the velocity is increasing, it is changing. The velocity is not uniform, but the rate of increase of velocity, that is uniform. So I can say the acceleration is uniform. Okay, please do not get confused between these two. Okay, velocity is not uniform, velocity is changing, then only there is acceleration. But whether the acceleration is uniform or not, definitely for a falling body, it is uniform because the velocity increases in the same rate. In the first second, 9.8 increased. In the second also, another 9.8 increased. In the third second, another 9.8. But when we are driving, what is the case? That is also non-uniform velocity. That means velocity changes, acceleration is there, but the acceleration is not uniform because the velocity sometimes increases at a very high rate and sometimes it is decreasing, sometimes it is increasing but at a slow rate. So the rate of change of velocity is not same over there. Okay, in first second, the velocity might increase 2 meter per second, and in the next 1 second, the velocity might increase 5 meter per second. So the rate of increase in every second, it is different. So that is why that is non-uniform velocity and non-uniform acceleration. But for a falling body, it is non-uniform velocity because velocity is not being kept constant. Okay, but acceleration, it is uniform because the increase of a velocity, it is the same. I don't know whether I could explain or not. If anybody have any doubt in whatever I said just now, please let me know. If some of you think that I went a little bit faster, then what you can do, just revise this,
Sir,
play it by pausing. Yes, Savia.
I didn't understood.
কোনটা?
একটুক্ষণ যে বললেন ইউনিফর্মটা velocity acceleration.
Okay, I think I need to write it on the board and then explain. Okay, I will write several. Okay, no problem. Acha. How many minutes? 4 minutes. Okay. Three case. Case 1, case 2, case 3. Let us study these three cases, okay? What does the first case tell you? With respect to time, is the velocity changing?
No.
The velocity is not changing, so it is uniform velocity. If velocity is not changing, then uniform velocity. What is the value of acceleration here?
0.
Very good. Acceleration is 0 because velocity is not changing, so the acceleration will be 0. Sadhya, understood?
Yes.
Now here, with respect to time, the velocity is same or changing?
Changing.
changing. So we can agree on this that this is non-uniform velocity. If you take a look at this, with respect to time, the velocity is changing or not changing?
It's changing.
Changing. So then we can say this is also non-uniform velocity. But we can clearly understand, even though both of them represent non-uniform velocity, there is a little bit difference between these two. Can anybody tell me what is the difference?
প্রথমটা ইউনিফর্ম অ্যাক্সেলারেশন আর পরেরটাতে অ্যাক্সেলারেশন চেঞ্জ।
Very good, excellent. Okay, here it is uniform acceleration. I will explain why I can say this is uniform acceleration. Because the rate of change of velocity, it is constant. In 1 second, how much it increased? In this 1 second, it increased 5. In the next 1 second, it increased again by 5 meter per second. Again, in the next 1 second, the velocity increased 5 meter per second. So the rate of increase of velocity, it is the same. Do you see it now, Sadia?
Yes, sir.
So here, the rate of increase of velocity, it is same. That is why we can say acceleration, it is uniform, because acceleration is the rate of change of velocity. Okay, we have less than 1 minute time. So here you can see within 1 second, the velocity increased by 5. In the next 1 second, the velocity increased 2, and then again
Changing.
11. So the rate of increase, it is not same, right? That is why it is non-uniform velocity and non-uniform acceleration. Is it clear?
Yeah.
Okay, so this is what I tried to say. Acha, okay, we have another period today, but teacher told to give you a 10-minute break. I think for today this much is enough. Kindly study this very well, okay? Inshallah, tomorrow we will
Okay,
take a
sir.
look at the equations of motions, okay? I think if I